And found the side length and put the side length equal to the top to make sure.
Oh, so you found y.
Sense.
So you found y, and then plug that in, and then put that instead of equal to x.
So we can get to that one. We can do that one.
Okay.
In 6.3, question number 3, asked you to show that this quadrilateral is a parallelogram. This is the same thing that was asked in these two questions. I think we did this one yesterday. There's no picture with this one, but they give you the ordered pairs. Here, they give you the picture, but they don't give you the ordered pairs, right? And this one, we can actually make our lives a little bit easier because there are some horizontal segments. So basically what's going to happen, to be a parallelogram, we need to demonstrate that UV is the same thing as TS. And we need to demonstrate that SV is the same thing as TU. Okay, we need to show those opposite sides congruent. So I'm just going to look at the horizontal lines for now. Okay, and we can see, I just got to pay attention to how the markings on the x-axis are done. They're going by ones. Okay, so I can see that I could basically just count that UV is 1, 2, 3, 4 units long. UV is 4. Is ST or TS, is that also 1, 2, 3, 4? That kind of makes sense? So both of those, 4 units long, and I can put a mark in them that they're congruent. Okay, so I got one pair of opposite sides congruent. Now, SV and TU, I cannot count because they're not perfectly horizontal or perfectly vertical. So there, we have to use the distance formula, which is what we did yesterday on the question where no lines were vertical or no lines were horizontal. We had to use the distance formula 4 times. But the distance formula says that you're going to subtract your x's, you're going to square that quantity, add to it the difference or the change in your y's, and you'll square that quantity. So all I've got to do here is figure out what are these ordered pairs. So this point S is at 0, 0. T is at 4, 0. U is at 5, 5. And V is at 1, 5. So if I want to find the distance between S and V, I'll just use those two ordered pairs. And it's nice that one of those is 0, 0. So the distance between S and V, so I'll subtract the x's, so 1 minus 0 gives me 1. We'll square that. Then we'll subtract the y, so 5 minus 0 gives me 5. And we'll square that. And it gives me 1 plus 25, which is radical 26. And they ask us to simplify, so if I look at 26, it goes down to 2 and 13 as factors. 2 is prime, 13 is prime. So there are no perfect squares that divide radical 26. So radical 26 is fully simplified for us. And then I just need to make sure, that UT is the same radical 26. So I'll subtract the 5 and the 4, and it gives me 1. I'll square that. Add to it, subtract the 5 and the 0, so it gives me 5. And again, 1 squared plus 5 squared does give me 26. So there we see that they're both radical 26, and we're good to go. Now, as you do this, so my thought is that maybe some of us are getting hung up on the radical simplified thing, okay? Like let's say instead of radical 26, I would have gotten radical 28. If you remember, the way we simplify this, we take our 28 and we start dividing it by numbers that divide completely into it. So 2 and 14 work, right? You're going to stop at the 2 because that's prime. And then you're going to go to the 14 and say, okay, well, 2 and 7 divide 14. You'll stop at that 2 because it's prime. You'll stop at that 7 because it's prime. Last year, we would circle groups of that matched, pairs that matched. So in this case, we got 2s that match. And that 2 can come out front of the radical. And the things that don't match go underneath the radical. So radical 28, if you were to use your calculator to verify this, A lot of your calculators won't simplify radicals for you, but you can simplify them by hand and then type in your two versions. So radical 28, see if I can edit that one. No. So if I go radical 28, and it gives me that decimal, and then 2 radical 7 gives me that decimal. And because those decimals are the same, then I know that I have equivalent formats for the radicals here. All right. Does that help with that question?
Yeah.
What was another one you guys want to talk about?
Maybe
10 on 6.4. 9 on 6.4. Okay. All right, so it says, so number 9 says, find the values of the variables, then find the side lengths of the square. Okay, so you know it's a square, right? So we should be able to create a bunch of different relationships, some of them useful, some of them might be more difficult than others to mess around with. You just kind of have to toy around with things here. Okay, so if I take, I take this 4x minus 10, I can set that equal to any of those things, right? Okay, so just listing the different maybe equations we could write, we could say 4x minus 10 is equal to y minus 3. We could say 4x minus 10 is equal to 2y minus 8. We could say 4x minus 10 is equal to, I guess 2y minus 8 is the same one there. Okay, so those are really the two relationships that we can look at comparing that to all the other sides, right? Another relationship is to say y minus 3. Can I say y minus 3 is equal to 2y minus 8? Does that make sense? Okay. By comparing that one to those two. And those are really, if we start comparing other things, we're going to get the same stuff again. So if I take 2y minus 8 compared to y minus 3, well, that's that equation. 2y minus 8 compared to 4x minus 10, well, that's that equation right there. Which of those equations would be easiest to solve? That one there, right? Okay. Now you can use this top one if you want to. If just kind of being creative here, this says 4x minus 10 is y minus 3. So down here where I see 4x minus 10, I could replace it with y minus 3. And that gets me exactly this here. So I think this is the equation that you're going to want to mess around with. If I want to add 8 to both sides, so give me 5. Subtract y from both sides. So it should give me y equals 5 in that situation, if I solve that equation. So if y is 5, this would be 2. This here again would be 2. That would be 2. And that's through evaluation, plugging in that 5 and evaluating. But we start to see the consistency that we should get if we have a square, right? We should have sides that are all the same. But now they also want me to find x. If I'm trying to find x, and I know what y is 5, can I come back up either into this equation here and plug in 5, which would make that right-hand side 2, right? Which should make sense. This 4x minus 10 to be a square does have to be the same as the other side lengths. And if I add 10 to both sides, I get 4x is equal to 12. And then x will be 3. Okay? I think all too often we might struggle with this type of question because we think, Oh, it's a square, so I take those two sides, so them equal each other. But if I do that, that gets me nowhere, right? There are other relationships there, and you just have to exhaust all your relationships before you come to an equation that you can actually solve. Okay, so some of you might have made those first and then got stuck and not know what to do. But those of you that made maybe that connection there first, you solve it almost instantly and don't even have to worry about the other ones. So that was question 9. Does that help? 10. Similar idea, different shape though. Not really a different shape. We'll talk about that. So my number 10 says find the values of the variables for the parallelogram. And then the parallelogram that they give us is this thing here. And I'll give you questions like this. I won't ask you. I might give you questions that are exactly like this, but there's also going to be questions that just give you that picture and ask you to classify that parallelogram. Anybody know what kind of parallelogram that is? Why? Okay, so if it's a parallelogram, then that means that side right there and that side right there have to be congruent because that's a feature about parallelograms, right? So if they have to be congruent and this side has one mark in it, doesn't this side have to have one mark in it? Okay, and for the same reasoning then, if that side has one mark in it, this side here needs to have one mark in it. So all sides have one mark in it. So far, we know it's a rhombus. Correct? Okay, because we got 4 congruent sides. However, in a parallelogram, don't we know that opposite angles, that angle there and that angle there, have to be congruent? So that's a right angle down there at the bottom. And in a parallelogram, we also know that consecutive angles need to be supplementary. So if that one's 90 there at the top, then this one here is 90. So I've got 90, 90, 90. That's 270 degrees. To make 360, this one's got to be 90 as well. So that knowledge right there, that information right there is enough. If I know it's a parallelogram, it is enough to tell me that it's a square. Okay? Now, if this word, just think about this, if this word was not parallelogram, but maybe quadrilateral, you cannot then classify this any better. Okay? Because this point here could be slid up here, so your shape kind of looks like that. Okay, so let me white some stuff out here. So if it was just it just said quadrilateral, my shape could look like that. Does anybody know what that shape is? That's a kite. Okay, so knowing our vocabulary is very important for questions like that. The process here that says find the values of the variables for the parallelogram. Well, if we know this is now a square, which means it's a rhombus, what does this rhombus, what does that diagonal right there do to that angle right there? Bisects it. So if that angle, that whole angle should be what? Should be 90, right? So 15x should be 45. Does that make sense? And then likewise 10z should also be 45. Here x is 3. Here z would be 4.5. What kind of angle, because this is a rhombus, what kind of angle do we have right here at angle 1? It's a right angle, correct? Okay. So then I could take, because I want to know what measure of angle 1 is as well. Or I guess I want to know what y is. So if I plug in 90 is equal to 3y minus 6, 96 equals 3y. So y would be, what, 32 in that situation? Number 12 asks you, they tell you this is a rhombus, okay? If this is a rhombus, what do we call this segment here that's going across the interior? Okay, so our for the rhombus is a diagonal, but for the angles then that intersects, it is indeed an angle bisector, okay? What do you know about opposite angles of a rhombus? They're congruent. Why are they congruent? Because it's a parallelogram. And one of the properties of a parallelogram is that opposite angles are congruent. And we proved that last week. So those two angles are congruent, okay? And if this diagonal is an angle bisector, doesn't that tell us then that this angle here and that angle there have to be the same? Okay, so I'm going to take 4x squared minus 21 and set it equal to 3x squared minus 4x. Okay, now if we look, that is what we call a non-linear equation. Okay, we've seen these before, but it's non-linear because if I were to graph those, we don't get lines, we get parabolas. Okay, do you guys remember how you solve non-linear equations? Okay, so we want to get everything equal to 0. So I'm going to take this 3x squared and subtract it from both sides. And I want to add 4x to both sides. Now when I do that, I don't have, so I got, obviously 4x squared minus 3x squared is x squared. Now I don't have a like term on the left-hand side to add that 4x to, so I add it to 0x's. So 0x plus 4x is 4x. And then my minus 21, and that gives me 0. Okay, so combining like terms that way as we set with the goal of getting the right-hand side to be 0. Because our goal here, whenever something is nonlinear, okay, so I want to say non-linear polynomial equations. The way you always solve those is to factor. And the only way we can factor is if one side is equal to 0. Okay? So what we're going to do now, if one side is going to be 0, we look for two numbers that multiply to give me that number, but add to give me that number. What are those two numbers? 7 and 3. So it's got to be positive 7 and negative 3, correct? And here's the reason this side here needs to be a 0. Okay, and I talked about this today with my college students. That has to be a 0 because if it's like, say it's a 9. How many different ways can you multiply numbers together to get me 9? Give me two numbers that multiply together to give me 9.
3 times 3.
3 times 3. Give me another set. 9 and 1. What's another set?
3.5.
Close.
4.5 times.
4.5 times 2. What about 1/9 times 81, right? That'll work, right?
Yeah.
Okay. So there's an infinite number of really ways I can multiply two numbers together to get me 9. Okay? And that doesn't allow me then to make a conclusion, because if somebody uses 3 and 3, you can say like x plus 7 equals 3. But then my neighbor used 9 and 1, so they said x plus 7 equals 9. And my other neighbor said 81 and 1/9, so they said x plus 7 equals 1/9. And you don't narrow your focus on the correct values that represent x. But if I've got two numbers being multiplied together here, and I get 0, what do you know one of those numbers, or both, have to be? Take any two numbers and multiply. Give me 5 times something, and you know the product is 0. Do you know 100% what that something has to be?
0.
It has to be 0, right? Okay. And that's called the zero product property, and that's why that needs to be a 0. Because now there's no ambiguity on what my two products are, or my two factors are, to get my product. Okay? So we take x plus 7, set that equal to 0. X minus 3, set that equal to 0. So x is negative 7, or x is 3. Now, when we do this, we could have some values here that might not work in the problem. Okay, so all this algebra here has no clue that it was attached to a contextual geometric problem, and these values represent angle measurements and so forth. Okay, so I'm going to try these numbers. I'm going to put negative 7 in here. What's negative 7 squared? 49. What's 49 times 4? What's 50 times 4?
196.
So 196 will be that total, right? 196 minus 21 would be?
175.
Okay. So we're saying that angle right there is 175. Okay. Therefore, what would this angle here be?
174.
175. Any concerns about that?
Yeah, because the thing is 3, so then it would be 9 times 3 is 27, minus 4 is, or something, they don't equal 175.
I would agree that 175 is an issue, but not for that reason. Because when we get to this point here, we have two numbers. So this x plus 7 represents a number, right? So is this x minus 3. They're being multiplied together to give me 0. So that means that one or both of them have to be 0. So I take that and I set it equal to 0, like I did here, and then solve for x. So when I subtract 7 from both sides, it gives me negative 7. Is it? 175 plus 175 is, you're on the right track, but that's not more than 360, is it? But think about what your diagonal does. It bisects these angles, right? So if this is 170, that's 175, that's got to be 175 as well, right? So there, with that being 175 as well, that blows up to 360. Okay, but even on a smaller scale, how many degrees should there be in just that shape right there?
180.
180. And 175 plus 175, that's 350, right? Okay, so that blows up that triangle. And then for the same reason, because that's 350, then like Joel was saying, that would eventually be an issue for the entire parallelogram totaling 360. Because that angle right there is also going to be 175, and so is that one. So negative 7 does not work. Negative 7 is an answer that needs to be crossed out. Let's see if 3 works. If I plug 3 in, what's 3 squared? 9. What's 4 times 9 then? 36. What's 36 minus 21? 15. Okay. So 15 is that angle there. It's also that angle there, right? Does that exceed any like polygon sums or anything like that we know? It doesn't exceed 360 when I add those together, right? It doesn't exceed 180. So far, it's okay. That would make this angle 150. That would make this 15, and this 150 as well. So that will be the only value that we're able to choose for that problem.
It's okay.
Yes?
I've really been thinking about this the whole problem. What plus 28 but adds 4?
I literally spent like 50 minutes.
28, so 7 and 4 is 3, right?
Wait, what?
9.
Wait.
So what are your what are your numbers here? You have
4x squared minus 28 and 3x squared.
You said what, multipliers?
minus 3, so that's where you put 4.
Oh, God.
So it's 7 and 4 for you. So when I combine like terms, move this 3x squared over, 3x squared, so it gives me x squared, move my 3x over as positive 3x, and then minus 28 is equal to 0. So now, because you said you had a 4 there, right?
Yeah.
Just be careful.
What did you do to your calculator?
You see where it says fix?
28.
What?
Wait, what's your 7 and 4? Good job. Good job. Good job, Joel. So is that what my answers?
Finding factors like that, so there's a couple different ways you can do this. I think the easiest would be to like if you've got it, does anybody have like you guys have this calculator on your computer still? Do they put that back on, or you don't have that? Does anybody have that as a handheld? Okay, so if you got that as a handheld, you can type in, I'll just demonstrate this and we'll show it somewhere else as well. Because a lot of people don't have right off the top of their head if I give you like 170 and I ask you what are two factors of 170 that multiply together give you 170, add up to 17, maybe you don't have that right off the top of your head. Okay? But doing the one that we just did, I had what, 21 and 4. So what I'm going to do is I'm going to take my 21 and I'm just going to divide it by x. Okay? And then I'm going to go over to second table. And you can see here, so what it does is gives me two numbers that multiply together to give me 21. Here are two numbers that multiply together to give me 21. Does that make sense? Down here, two other numbers that multiply together to give me 21. So I look for the whole number factors. And so I'm going to look at this 3 and 7. And we'll say, okay, well, what combination do those add to give me 4? Okay. Does that kind of make sense to everybody? So if I gave you, let's say we did, let's say I had x squared plus, let me just figure out one here real quick. What if I gave you something like that? X squared plus 22x plus 105. Okay? You'd be looking for the numbers that multiply to give you 105, but add to give you 22, right? And instead of sitting down like you did last year and say, okay, well, 1 and 105, 5 and 21, okay, and figuring out all those factors, the quick way of doing that is going back to y equals here. Type in 105 divided by x, then go to your table, and you're going to go find the whole number. So 1 and 105 are factors, 3 and 35, 5 and 21, 7 and 15. And 7 and 15 are the ones I'd be looking for because those add to give me 22, right? So those are my two numbers. If you don't have that calculator, you can do the same thing with Microsoft Excel, which everybody has this on their computer. Which Microsoft Excel, just a giant calculator. So what I'm going to do here is I'm going to type in like 1, I'm just going to type in my integers, 1, 2, 3, and you can type those in as far as you want, but I'm going to type in 1, 2, 3, and then click and drag. It'll fill them in automatically for me. And now in this cell, all I'm going to do is I'm going to take the I'm going to hit equals 105, and then divide, and I'm going to click on that cell right there. So I know it's kind of hard to see. Let's see if I can zoom in here. All right, so in this column, all I did, and these basically are going to be one factor. Okay. I take then in this cell 105 divided by A1. So that means it's going to take 105 and divide it by whatever I put in that cell. Okay. Then what I'm going to do is I'm going to click on that and drag this bottom right corner all the way down. And what it's going to do is it's going to take 105 and divide it by 1. It'll take 105 divided by 2, 105 divided by 3. So again, it's giving me two factors there, two factors there, two factors there, 2 there, and those are the two that add to 22. Okay, does that make sense? Yes. But it's the C term that you're looking for, and then divided by what is in that first cell, A1. And what Excel, I think people use Excel a lot of times just to like organize like rosters and spreadsheets and that kind of stuff. It's a giant programmable calculator. So we could actually set this up a lot more detailed where we could just type in like the A, B, and C values of our quadratic and it automatically fill things for us. Maybe down the road, if we've got time, we'll spend some time maybe constructing something like that. But there are ways. I don't know if Desmos has a ability to generate that for you. It does. We could do it this way, I think. I could take 105 divided by, I'm going to say A. You see how it says select a slider or create a slider for A? I'm then going to say A. I'm going to make it, I can change it from 1 or I can make it 2, and you can see now 2 and 52.5 would be my factors. I can change it to 3, I can change it to 4, 5, 6, I get to 7, and now you can see that those are indeed those. You can do it this way too, instead of having to delete, I was deleting it. If I put in just my lower value, then I'm going to try 1, and let's go up to like 30. See where it says step? Step means what is this value going to change to as we move our slider left and right? So let's step it by 1. And you can see now that so I'm at 1 here. As I move this slider to the right 1 unit, it's going to increase by 1. So I'm not hitting my decimals. If I don't put that step in there, you can see that I get, for those A values, right now it's going by tenths place. So maybe a little bit harder to get to that whole number. But those are maybe some technology pieces that can help you determine two numbers that multiply together to give you a product and add to give you some sum. Anything else on here you guys want to talk about? Any? Yes? 11? I think that question there is a snapshot of mathematics where, and especially a lot of things that we do is kind of called applied mathematics right now, because we're taking the algebra, we're taking these properties and working inside like authentic, new, different problems. And you don't know what kind of math you're going to run into when you do that. You might end up solving a linear equation. You might solve a quadratic equation. You might have to use the quadratic formula. You might have to use a rational equation. So all the things that we've learned in Algebra 1, the idea is that and it's a terrible assumption, but we mastered that and we've never forgotten it. And we know exactly what to do when we see something like that arise in a geometry class or maybe a trigonometry class or something like that. I think that's the hard part about mathematics, is not applying the new stuff we're learning recently, but when we do apply that new stuff recently and it generates an equation that we haven't seen in 2 months, 3 months, a year, do we remember how to solve that equation that just got generated? Number 11 says we've got a rectangle. Find the length of each diagonal. Okay, so if we look at this, let's draw a rectangle A, B, C, D. I think that's going to be beneficial to us. So here's A, B, C, D. So the nice thing here is that they tell us what AC is. So AC is, I'm going to write it as 3x minus 9. Is that okay? Just distribute that 3. What do you know about AC in comparison to BD for a rectangle? They're congruent. So their distances should be the same. So 2x would equal 20. In this case, x would be 10. If I plug those in, I'll get 21 there. And then 3 times 7 will be 21 there as well. Does that help? I was just going off the fact, yeah, sure, that we talked about that what makes essentially what makes a rectangle unique or special is that the diagonals are congruent to one another. Got it.
Are you getting homework from me today?
Yeah.
So you just equal to each other?
Yep. Yep.
Oh, okay.
Anything else?
I'm fine.
I was one for like the boxes and the
Oh, it's like yes or no questions.
Yeah.
Oh. Yeah, those are my yes and no. I did not do good on those.
Do you know what these here? All right, so opposite sides are parallel. You guys can't see it, we're on screen. There we go. Opposite sides are parallel. Is that true for a parallelogram? Okay. Do I need to think about any of the other questions? Why? Because all of these are parallelograms. So if it was a yes here, then it's got to be a yes for all of these. So is this, I just want to see if, okay. I was hoping that this would change this property here and I could just do it that way, but. So yes for all of them, we'll check answer. Okay. So now the next one says opposite sides are congruent. Opposite sides are congruent. Is that true for a parallelogram? Is a rectangle a parallelogram? Yep. Is a rhombus a parallelogram? Yep. Is a square a parallelogram? Yep. Okay. Opposite angles are congruent. Opposite angles are congruent. Is that true for a parallelogram? Yep. So it's true for a rectangle, right? True for a rhombus. True for a square. all sides are congruent. Is that true for a parallelogram? No. So now, because that one said no, there's going to be other ones. Now I got to think about these. Okay? Are all sides congruent in a rectangle? Nope. Are all sides congruent in a rhombus? Yes. Now, is a rhombus or is a square a rhombus? Yes. Okay? So I guess what we're saying here is if a rhombus gets checked yes, your square better be checked yes. Does that make sense? Okay, so this one says it is equiangular. Or what's equiangular mean?
All the angles are...
All the angles are the same. And we're talking about quadrilaterals here, right? That's what this is saying up here. So that means all angles would have to be what?
90.
90. Is that true for every parallelogram?
No.
No. Is it true for every rectangle?
Yes.
Yes. Is it true for every rhombus? No. Is it true for every square?
Yes.
Yes. It's equilateral. What's equilateral mean? All the sides are the same. Which shapes up there do we know that all sides are the same based on its definition?
Square and a rhombus.
Square and a rhombus. And rectangles, no. Parallelograms, no. Can a parallelogram have all sides congruent?
Yes.
Yes. But if I tell you, like the idea that you want to take and answer these questions with is, like you have your eyes closed and I put a shape on your desk and I tell you what it is. I say parallelogram. Based off that, without touching it, without seeing it, can you tell me all the sides are the same? No. But if I tell you I put it on your desk a square, without seeing it, without touching it, can you tell me all the sides are the same? Yes. Okay. So that's kind of the idea of how we want to answer these. Equiangular and equilateral. What's another word for being equiangular and equilateral? It's regular. Good. Okay. Is a parallelogram, close your eyes, put a parallelogram in front of you. Can you tell me it's equiangular and equilateral? Nope. Can you do that with a rectangle? Nope. Can you do it with a rhombus?
No.
Nope. Can you do it with a square?
Yes.
Yes. All angles are right angles. Did we already answer this question?
Yeah.
Right there, right? Just a different way of saying it. So we said no there, yes, no, yes. Diagonals bisect each other. Does that happen in a parallelogram?
Yeah.
Absolutely. So does it happen in a square then? Or a rectangle? So in all of them. Okay, so if that parallelogram says yes, then all yes. Diagonals are congruent. Is that true in a parallelogram? And if you can't convince yourself of some of these properties, draw a picture. And if you know what a parallelogram looks like I go back to maybe this picture right here. This is a parallelogram. Does this diagonal right here look, I know going off looks isn't always the best thing to do, but we can here. Does that diagonal look like it's going to be the same as that long one? No. So diagonals of a parallelogram are not necessarily congruent. Are they for a rectangle? Yes. Are they for a rhombus? No. Are they for a square? Yes. Why are they for a square? Because a square is a rectangle. Each diagonal bisects opposite angles. That does not happen in a parallelogram. It might look like it. We should probably talk about this. Like if I look at, let's see here. Show. If I look at that diagonal, okay, does it look like this angle here and that angle there are the same? Just based off of looks. But if I measure these, that's 38.66. And this one here is, okay, so in this situation, I do have this. So this must be a rhombus here that I've got created. So let me do, if I can move it, there we go. the way I've got this set up, it's always a rhombus. Let me go to my app that's got a parallelogram. I'll just make parallelogram. All right, so that thing is a parallelogram, okay? And the parallelogram that we kind of maybe think about initially all the time, I would argue would be kind of like that one, okay? We can change the kind of the degree, the slope of things here. Let's look at this one and look at the diagonal here. If I look at that diagonal, does that diagonal look like it bisects these two angles? Okay. If I look at the angle here, that one's 21.58. Bottom one's 21.58, top one's 22.64. Are those congruent then? So does this diagonal bisect this angle? No, it looks like it, and our eyes can't tell the difference between, you know, a little bit more than 1 degree. But in general, a parallelogram, the diagonals do not bisect opposite angles. Okay, so that would be no. In a rectangle, the answer is no as well. In a rhombus, though, the answer is yes. Okay, that was the situation that I was showing with this here. This is a rhombus. So there we're seeing 33.85 and 33.85. Okay, so we do bisect opposite angles there. Does it happen in a square? Do diagonals bisect opposite angles in a square? Yeah, because it happens in a rhombus, right? And a square is a rhombus. Diagonals are perpendicular. Does it happen in a parallelogram? No. Does not happen in a rectangle. It's only a feature for rhombuses, but since it's a feature for rhombuses, it's also a feature for squares. I will probably, on every test and every quiz that we have in this, from this time forward, those 3 questions will be on there. Okay? Because you can answer those 3 questions, you know these shapes inside out. You know all the properties. Okay? And that's the goal as we move forward. We'll stop there for today. You got a question?
Yeah, man. You did 10.
We did 10, man. All you got to do is go back to the video then. So Thursday, we're going to have a test. I'm going to open up a optional review. We'll probably do that next period at some point. That'll be due Thursday. Test on Thursday. We've pretty much covered everything that I want to cover in this chapter. There are some outlying kind of questions that we can do with the coordinate plane, which we might cover, but concept-wise, property-wise, we've covered everything that I want to cover.
Will the test and review go in the third or second?
Second 9 weeks,
Oh,
yep.
like